All right, hello everyone. Welcome to ECS 179 Gameplay Programming. Today we are going to talk about the component pattern. You have your last assignment. It's given out to you now. It's on the factory pattern. The component pattern is something I want to talk about and cash out, but you've been using it all along. It is at the core of Unity's game object implementation. So in essence, every time you've made a script, attach it to an object or put a collider on an object or even the simple transform, all of those are components in the object model. So game objects are simply containers of components. They have very little functionality in and of themselves other than to act as a bridge to the components to the larger architecture. So we will dig into this and we'll look at how you would construct a game-like object and then break it down into, first we'll motivate the need for components, then we'll break it down to some actual components and show you what's going on. And to help you cash out this learning, for it to help stick, we're mirroring and using the examples from the Nystrom's text. So let's get started. How many of you have played with this or have done this PC building yourself? Yeah, I love building PCs. Definite hobby of mine. Been doing it for a long time. Got paid to do it in high school for a while, that sort of thing. In the PC heyday. So what's great about PC building is everything has a nice little interface. It's very hard to mess up installing components now because everything has the exact type of socket for it to fit in the exact place on the motherboard or to SATA controller or M.2 slot. All of these things are standardized, and if a component can fit into a slot, it typically works on that motherboard, right? So there's a contract between components via this interface. And there's the hint there, right? They call these components. You're adding in PC components, whether it's CPU, GPU, physics cards, memory storage, a fancy wireless card with way too many heat sinks and fins that are completely unnecessary. It's all there, right? And it all probably has RGB lights on it, right? RGBs. So component pattern. We'll give you a little flavor where we're going. Maybe give you a little flavor of the next slide too. There we go. Setting the stage. So this is where you will be going for this information. I'm not sure what's going on right here. I don't want to attach a debugger. Okay, fine, whatever. We'll just move forward. Not important. So this is in the Nystrom Game Programming Patterns book that we've been using for class. So we'll follow along this example. I think this is one of the more interesting examples from that text. Enter Bjorn. Bjorn is a character in our upcoming Viking exploration game. Perhaps, we're even making a knockoff of Vinland Saga, right? So we want to make sure that we have a character that we can represent in a game and has all the bits in a game that we need to track for a character. Things like responding to input, interacting with the physics engine, interacting with the graphics libraries. Sound has to have some aural capabilities. Behavior wants to move or interact with some way, right? So all of these are capabilities that Bjorn should have. Well, let's start building a Bjorn. So here we have the classic first run implementation that people tend to start with when creating a character like Bjorn in their own game. So this example is in C++. I'm assuming almost all of you have had extensive C++ experience, and now you have some pretty good C# experience, and the translation between those two is pretty straightforward. So this is easily adaptable to our Unity world. All right, so first we have a class definition, Bjorn, with a few public members and attributes. So we have a constructor, which takes a velocity, an x and a y value. We have the headers here for void update, so we're declaring what these function signatures should be. We have an update function, which takes a reference to the world state and a reference to the graphics engine. And here we have a few interesting attributes here, like a static constant, walk acceleration. So things to help manage movement and speed, things for us to change and parameterize. We have the current velocity of Bjorn, and we have Bjorn's X and Y locations. And we have Bjorn's collision volume. We have the sprite, a reference to the sprite, where a sprite is standing, or when we're walking left, when we're walking right. All of these are assets we will use and give to Bjorn. The assets and their parameterizations are not particularly germane to this discussion, so we're just going to assume they exist. Now here we have the .h file, now we have the .cpp file, where we have the implementation of the functions and things that we've defined on this side. We're going to take a look at update here. So update takes a world object and a graphics object. And what we're doing here is first, we're handling update, right? We're handling input and updating the character based on input, right? So we have, we're getting a reference to the controller. We're getting the joystick direction. We are seeing if it's left or right, and we're changing Bjorn's velocity accordingly, right? Pretty standard stuff. And finally, after we've seen the delta velocity, or after we've calculated velocity, we are going to update Bjorn's X and Y values based on that velocity, right? So there's probably some time.delta time magic coming in here. Sub in your movement algorithm of choice here to update X from velocity. And finally, or not finally, but next, we're taking a look at the world collision. So we're seeing what in the world, given the collision volume and X, Y locations of Bjorn and Bjorn's velocity, let's resolve the collisions. What did Bjorn run into? Is Bjorn going to stay on the floor? That sort of thing. So all those physics interaction details are sort of handled in this resolve collections function that belongs to the world, which makes sense. We don't want to replicate that same basic physics logics in every single game object we create, right? So that's externalized, but the hooks to it are right here in Bjorn. And then we have our graphics code, where we take Bjorn's sprite and we see which direction he's going. Is it negative or positive velocity? Particularly, we're looking at whether Bjorn can move left or right, where it looks like we're in a side view 2D world. And so if the velocity is one direction, we walk left. If the velocity is another direction, we swap the sprite to walking right, right? Just like we did with the pirate. And then finally, after we pick the sprite, we want to draw the sprite at a location. Right, so all this, I'm hoping, makes pretty basic sense to you, right? But there's a problem here. This is a monolith. All of this code exists in one function, right? Who can tell me what's wrong with this? I'm setting you up for an easy one. What's wrong? What's going on here? Why do we not want monoliths in software engineering? Yes.
If there are going to be other characters, then you want like more general class, like the same class that you want, and then like extend that class and make those characters.
Yeah, there's a case for extending this code, not repeating code, keeping it dry, that sort of thing, right? Definitely, yes.
Also, if you're like, for example, it's like good to have the code separate. For example, when you're doing collaborative coding, like you don't want everyone to be editing the same file and having a bunch of like git merge errors.
Exactly. So this is a symptom of the larger problem, right? Where if code is all in one place, it's hard to track that. Even our best text differs have a hard time with game logic changes, particularly attribution. Like if two developers make changes at the same time, they both want to merge and the merges conflict. How do you resolve it? Right? That's tough. So if you break down things into smaller chunks, you have less rates, less conflicts, less collisions in merge time, merge space. All right, so that's getting closer. What else do you got? Yes. Right, it's harder to test big functions than it is small functions, particularly with unit tests. Yeah.
If
add more functionality, eventually this class is going to be like thousands of lines.
Yeah, and so this class will balloon, get bigger as we flesh out Bjorn's implementation and make Bjorn a more fully fleshed out character in the game world. That comes at a cost, right? The bigger the function you have, the more error prone it is, the more dependent it is on other things. So we're having one function that's very important. Bjorn is a core figure in our game, and Bjorn is now becoming, the chance of Bjorn becoming bug riddled and brittle is quite high. Also, we have some Gordian knot issues going on here. Bjorn touches many domains: physics, collision, graphics, sound. Right, so if colliding with floor and get render state invisible, place down hit floor. How many different subsystems is this if statement plus its one-line body touching? How many dependencies on various large portions of our code base does this simple statement have? Colliding with floors. Getting the render state, so the graphics engine, physics engine, graphics engine. And it also touches the sound engine, right? Play sound, hit floor. Right? We're touching in this one line of code like 3 major gameplay systems. If any one of those changes, or their API changes, or their implementation level details change, we got to update this function potentially, right? So here we are just asking for side effects. We're asking for bugs that we haven't thought about, don't understand, don't expect appearing in code like this. Right? This is sort of where software development, debugging, and maintenance nightmares are born from. This is nightmare fuel. Hey, we've said this word before, right? Decoupling. So we can use classes, but it's hard. Duplication's still a problem with this, right? So notice that for a game object, let's say we have a zone, and zone has collision decorations, and we have decorations, and they have rendering, and we have props that has rendering. So all these things have to be drawn in the world. Notice that we duplicate this rendering code, right? So this isn't good. Rendering is there twice. So what if we swapped prop to inherit from decoration? Well, then they're both rendered there, but you still have to collide with the props, right? The problem is that prop needs both collision and rendering. So no matter which side of this inheritance tree you're on, you're duplicating code. So this is a classic deadly diamond of inheritance, right? So if we have more than one ancestor that we care about. Like if we wanted to not duplicate code, we'd have prop here needing to inherit from decoration and inherit from a zone. Have you ran into a programming language that supports multiple inheritance? How many of you have you? Does it? Does C++ support multiple inheritance? You'll often see multiple things in the inheritance line, but does it support multiple inheritance? What about C#? Nope. What about Java? Oh, Python. It's pretty uncommon. I know C++ is not a language I use often. If it has multiple inheritance, it must be a newer thing. When I did a lot of parallel programming in C++, it certainly was not a capability. So I'll have to look into that and get a modern take. If you have documentation, please send me. Worth participation points if you can make me learn something I didn't know. That's most excellent. I appreciate that. But it's still uncommon and rare. And you still have this problem of, in most languages, you have this notion of where you inherit from where. It can lead into cycle problems. So the reason why multiple inheritance generally isn't allowed, because you have this ontology, this tree structure that your classes are implemented in. And if you sort of break that into a directed, or if you break that into a directed like acyclic graph or something like that instead of a tree, then you're introducing a lot of compiler inefficiencies and perhaps unresolvable compile time or dynamic runtime errors. So this is tough. This is what a component pattern helps us solve. Particularly, it helps us break those multiple inheritance deadly diamonds. So we want a single entity that spans multiple domains, but each domain should be contained within a component class. You can see this in Unity, right? We have the mesh renderer separate from our line renderer, separate from our mesh filters, separate from our scripts. And you can only have one of each type of component on a game object at once. So here, we often see this as entity pattern. Game objects are types of entities. These game objects / entities they're simply really just containers of components. They end up being aggregators, which is the heart of this pattern. They're a logical aggregator that has less domain in and of itself, but supports the application of many domains. Let's start building this out. Let's motivate this. All right, so how does this solve the problem, right? So taking a look at this, if we look at this to the side, we have a decoration, which is graphics. We have a zone, which is physics, and we have prop that relies on both graphics and physics, right? So we're taking a look at this. We're doing a little decomposition here. Now let's start splitting these things up and see how we can resolve this. So first, so I am recording this, and I will send out the slides. Hopefully you can see it. It's a little small on the TV, the display on the left, but I think it's much more legible on the larger display, I guess on your right versus your left. So let's split it up. So first, let's look at the input, right? That input code is at the top of update. That looks like a good candidate to pull out into its own class. So now we have a class input component, which has its own update function. It takes Bjorn as an object, right? So it takes a reference to a game object and has its switch statement that gets the controller to joystick direction and swaps velocity left and right, right? So we're changing aspects of Bjorn, of the component sent in. Okay. And we also have our acceleration value now packaged into the input component to manage the move and acceleration of velocity. I'm losing my mouse. Okay, there we go. So this changes Bjorn, right? So now with Bjorn, we have our update function. So here we're going to look at the CPP file, look at less of the header, just to fit everything on one slide. Now our update function is a little different now. It's a lot smaller. So all of this code that was used to update that we saw here, particularly right here, is now in the input component, which means we need now a reference to an input component. And then we call update with this. Right, so now we're sending this information to the Bjorn object, a reference to the Bjorn object, into the update function for the input component, and it's doing this level of input update, and now we can rely on it. Now, the velocity's been set, we can do collisions, and we can do our sprite drawing, and we're off to the races, right? With the addition of this input component being now part of the class. So, you may be thinking, hey, Josh, Professor McCoy, this isn't components. We're simply just stubbing something out into another class. The brittleness is still there. You are correct. So let's continue on. Let's pull graphics out. So now if we create a graphics component, and we do the same thing, so we have, did I miss one? Okay, so there's a physics component here too. So input component, we have that. We have we now pull out the graphics component. Right, we do the same thing for physics, so it's the same concept. So with graphics component, we pull out its own the code that was in Bjorn's update into the update of the graphics component, and we do our sprite logic, checking our Bjorn's velocity, and then we draw it at Bjorn's XY positions after all this has been updated. Call graphics.draw. So all the graphics calls, all dealing with sprites, are now in this graphics component. And the physics component is pretty trivial, right? So basically, it's resolving the collision. So it could be more intense, right? But in this case, for this particular example, it would be making a physics component that has one line in the update, which is doing world.resolve collision with all of Bjorn's attributes. It would also probably hold a collision volume as well. All right. And you can see there is no collision volume now in Bjorn, so it is tucked away in the physics component. So now our Bjorn's looking much less complicated, right? Bjorn is now velocity, 2D position, an update function, which still needs the world and the graphics engine, still needs to talk to the engines, but calls updates, and now has a reference to each one of those components. So is this easier to maintain now? Have we done ourselves any favors? What do you think? We have a lot more files to work with now. Any thoughts? Girl software engineers, you should be like, all computer science, you should be like really trying to dig into this, right? Is it too gray outside? All right. So, in my opinion, this is much preferable, particularly because it's much easier to extend. Right now, Bjorn is like prototype or alpha Bjorn, right? Barely exists. There's not a lot of game logic, game mechanics, implementation in Bjorn. This is a toy Bjorn. And we now know where to go. When there's something we want to update, we change the graphics engine, or we want to add some like special type of collision or a speed boost or something. Now we know where we need to go. So let's say if we wanted to add a dash capability, right? We know that the dash is broken up into several components, right? So dash is about input, right? So you need to know when dash should happen. That's a player input interaction, so we'd change input. We know that dash needs to be kept around as a dash state, so we'd that's probably Bjorn specific, so we'd maybe keep dash state in Bjorn. We also want to update the physics, X and Y, the locations, velocity, etc. So that's part of dash. So we want to make sure that when we're in the dash state, our physics is updated appropriately instead of just moving like left and right, standard joystick walking. And then we also have probably some graphics that go along, maybe a particle effect of trailing smoke, maybe a flash effect that shows the displacement. Classic stuff, right? And that would go in graphics component, right? So now we know where when we want to implement something, we now know where each parts of it go. And instead of this big monolith function that, you have to find out, like first parse, like where is it in this function? Where should I change it? Where are the side effects of me changing it? Is the ordering matter between these things? There's a lot to think about when you add something into a larger chunk of code. Now, with it broken down here, these tasks are much more simple. Right? So now we've reduced a lot of this complexity into these components. And each one of those are much more simple to manage. Right? So now we have multiple simple management tasks as opposed to one more difficult management task, which generally is better for you creating code that is maintainable, bug-free as possible, and maintainable. But we still have these hard references, right? We're still not like Unity drag and drop component stuff yet. This is where our last layer comes in, component abstraction, right? So now here we have, input components. Notice that we have a tilde here, right? This is now a virtual input component function. What does that mean? Who can explain to me what virtual functions are and how they're used in C++? Yeah, it's just like interface, right? It's like, you need to have this function. I'm going to mandate you make it for me, right? They're just like delegates, right? You can pass in functions. They're like our interfaces we've been using pretty extensively throughout the exercises, right? So here we want something, a reference to an input component, right? That we can then make and use. Right, so here now our Bjorn constructor now hold something interesting, right? Now our Bjorn constructor takes an input component and can take, one that exists by default. So now Bjorn takes a set of components when it's created. Right now, this is cool. Now we just have a reference to an input component and not have to define one that stays around and is inside of Bjorn itself, right? So now what we're doing is we're externalizing components into something that's contract-based. This may start looking familiar to you now that you made your own mono behaviors. And so now the updates here. So input, we do a reference call to a referenced instance of inputs update function instead of a direct instance, right? I'm sure you've handled this a bunch of times. The good thing about C# is that this kind of gets handled for you in smart ways. You don't really have to use the arrow operator. A little too low level for most of our programming needs. Good to know about though. And we can extend this now to physics and graphics. Right, so this is the key here. So once we do this for physics and update components, now our Bjorn is now a little different, right? We can now have Bjorn be defined as a set of components that gets sent into it, right? And so each one of these components can now, as long as they adhere to the component contract, can be swapped in and out. Right, so now instead of Bjorn being controlled by the player, we could even hot swap Bjorn to be controlled by some script or some AI method or some network stream, right? What do you think this would be handy for a player character like Bjorn to have his movement swapped out from player controlled to something else controlled? Yeah? RTS? Yeah. So you could have a path planner or a unit squad manager. Yeah. Any other thoughts? What's a good design use case for this? I'll put one out there. In-game cutscenes. Any others? Yeah.
Maybe you have a game with multiple characters, and sometimes you could have it be co-op with your friend playing their character, or maybe other times they're not available, so it's an AI that takes over.
Exactly. You could, particularly for couch co-op, right? You can swap the characters from being controlled by human to players anytime you want. Mind control abilities in things like MMOs or RPGs. Right, all of a sudden you lose control of one of your characters or the character you're controlling, and it's controlled temporarily by some process. Typically a behavior tree. All right, so now we have all sorts of cool things here. Also things like Dragon Age games where you can swap the active controlled character. Star Ocean series. The Final Fantasy VII remakes and Final Fantasy 16. No, Final Fantasy 16 you only controlled one character. Take that back. But you could swip between the summons, the icons. But the others hold true. You could control a lot of characters in Final Fantasy 15 as well. Right, so this is pretty handy. Oh, you can't swap control to the other characters. Am I just misremembering 15? I didn't play a lot of it. Oh, you're right. Okay, so we'll just stick with 7 as the example. 7 remakes. Thank you. Pardon me, everyone. Great. So now we can do this, but we can also do this for graphics. We can do this for sound, right? You can start subbing out all these systems. This gets us some interesting capabilities, right? Now all of a sudden we're in this perhaps dependency injection or dependency controlled world. Let's say you did this with debugging. What could that get you if you had your debug components being able to be split out? You could re-implement, or you could put a different debug component into your debug slot. How could this be handy? your software engineering cap on. How would you extend information that you need to debug characters and the capabilities those have out in the world? I mean, the first order one is like you're debugging a console, right? How would you replace that with something else? Like what's another interesting place for that information to go? Yeah?
Probably a text file.
A log file, right? Classic like Apache logs or like Log4C, this sort of stuff, right? What else? Where else could information go? Yeah, a console that you could then edit and play with, right? You could have a reference, that debug log has a reference, just like all the other components, to Bjorn, to that game object. You could then, at the console, just like maybe give Bjorn some power-ups, right? Classic game dev stuff. Like these consoles, these dev consoles have gone way back in history. What else?
Analytics, you can see what there is stuff.
Exactly. The logs now can go somewhere else. To some NoSQL, some relational database, some log collector, some debug functionality. This is incredibly popular when you're playing betas of games, right? Often they'll have that little debug window, right? Where you get to send debug information out. And so that can collect a bunch of information, log it from all these game objects, and send it out. A lot of times, this sort of thing is now, collected by A/B testing, right? Zynga is pretty famous for this. So we have a strong case here for this abstraction, this component level abstraction, not only to make our software engineering lives better, but it also has like important impacts in both the game and the life cycle around the game. Right, and so the pattern can be pseudo-finished here. There's still, I think, one more interesting step you could take past this. But now, our Bjorn is a set of components. So now physics component, graphics physics, so graphics component, like all of these are components you could use. These are specialized to Bjorn, but they can inherit from a basic graphics component functionality. So now you can have an ontology of components, and then each one of these, like the physics component, Bjorn physics inherits physics component, Bjorn graphics inherits graphics component, and all of these can be sent to Bjorn. So Bjorn simply needs an input, a physics, and a graphics component. You could have Bjorn graphics be like a normal Bjorn to mythic Bjorn to super special like Lunar New Year skin Bjorn, right? So this is where you can start like swapping out these graphics packages and these sound packages and these animation packages, all right here at the component level. It makes it quite interesting and efficient. And so each one of these components has their own domain, just like Mesh Renderer, just like colliders. So each one of those are a component archetype, and you can swap those in and out. In Unity, you can take most of these components and you have them inherit model behavior, somehow munge them, and you edit them yourselves. And one of the key things here is a lot of them hook into the larger component lifecycle of a game entity, right? Like here now, instead of having Bjorn, we have a game object, which the only thing specific to a game object has a velocity in X and Y, and this particular game object requires input, physics, and graphics. Right, and then we simply pass our update call, our update cycle, into the updates of the individual components. All right, so now Bjorn is this is a thing created from an abstract. This is sort of a canvas that you can make a Bjorn from. And the paint and the things you put on that canvas are these components that you have customized to be Bjorn-like. So also, you could even perhaps take this one step further and have a game object just take a collection of components. And each of those collection of components needs to, have an update function. Right? So you can really abstract this out pretty far. And a component can simply be an interface that simply makes it so you have to define a void, an update function that returns void and takes a game object. Hey, that's looking pretty familiar, right? Now we're getting pretty close to what Unity is thinking about here. All right. So this is sort of like making the case. We've stepped through the component abstraction pattern. We've made a case for components. We've decomposed Bjorn. We've deconstructed him like a very fancy dish in a expensive restaurant. What do you think? Well, have you decomposed code like this before into more efficient, maintainable, scalable structures? Yeah.
Have you ever seen the player.cs file in Celeste?
No. I've seen the Celeste implementation pretty extensively in Pico 8, but I haven't seen yeah. What about it?
So it's like 5,000 lines long because they don't split it into components, but they sort of wrote this thing in their readme that if they did split it, then they would sort of be hiding the order of execution, and plus only one thing is doing one thing, right? It would only be important. But I'm not sure if it would have been better or not if they did split it up.
Yeah, so I mean, if you are a small development team or a single developer who can pull off like a savant level implementation of one particular thing in 5,000 lines of code without it causing you severe drawbacks, then I mean, there's a case for it. But I think that's more of the edge case. I think this is more showing the capability of that developer more than the usefulness of the component pattern. Who knows what they could have pulled off if their game was larger in scope, like if it was more than just Celeste being the basically about the only thing that has a lot of capability in the game, then that would be great. Now, particularly with Celeste and its design, I mean, there are spikes, there are some moving things in the world, there are small levels. Like it's all of the complexity really is in that character and that character's moving and its bespoke nature, right? So, I mean, if you're not going to reuse the code, then there goes a good chunk of the utility of a component pattern, right? Because it's not like you're adding a bunch of physics and graphics objects to a bunch of other things in the world. A lot of them just don't need that complexity. Yeah, interesting example. Thank you. All right, so this is good software level engineering, and this sort of like also opens the door to some functional programming. For those of you, I know there was some discussion put in on the Discord server about, at least some article about why do you even need software design patterns? Why doesn't functional programming solve everything for you? Well, it's basically doing the same thing in a different language paradigm. We're basically cutting out the coupling. We're cutting out the side effects between areas of code, and we're trying to manage that inherent like interdimensional complexity of creating complex software artifacts. Enforcing the rules of side effect freeness, such as in Rust or in functional programming, that's one way to go about it. Another way is to use the tools we have for object-oriented programming and basically doing the same thing. Now, I kind of like these mixed mode projects, which can be kind of fun. Like if you're in .NET or if you're in Java, you can like have both like Clojure, Kotlin, and classic Java like running in the same JVM. And depending on the type of problem and how it decomposes, you can use the right programming paradigm for that particular problem. Right? Use the right tool for the right tool set. Right? It can really help simplify your life. But that's a little, a little more niche. But I think it's fascinating to think about and maybe integrate in some of your practices. Not everything's Python these days. All right, so here's the component structure of Unity. You can find this in the images section, and in the figures or images. Maybe it's in the resources folder in the class repository. So the thing we want to focus in on here is actually component, right? So we have objects, Unity.object, which has the large containers, the top of the hierarchy. It has game object here. Game object actually, if you look in the reference, has can be collections of components. And so components can have behaviors used by a bunch of things, and then eventually it exposes mono behavior, which you've used a lot. So mono behavior is a type of component, so it can be stuck onto a game object, which has a collection of components in it. Transforms rigid bodies, renderers, colliders, all of these all speak this language of component. All can be a component and therefore be placed on a game object. I encourage you to go through and look at the documentation. It's pretty revealing, and I'm happy to do this with office hours for people who are interested. Just like troll through the documentation and like connect these dots. You know, it's not an open source platform, but I think the things they put forward in the API documentation can really help you like piece together these relationships. One of the cool things is scriptable object, right? Which isn't really a component. It's code that you write that is scriptable, but kind of like lives in its own space, which means it's not hooked into the same update cycle. So, you know, all of those components we had with Bjorn, their thing they had in common really was they had a reference to Bjorn and they had update. Scriptable objects aren't hooked into that, but they still exist as code and something you can run, just not heavily embedded in a lifecycle. So I encourage you to check this out. All right, any questions or comments about components? Go ahead and leave this running. Sorry. I guess maybe I'll leave this example up while we talk. Yes.
Isn't the command pattern just like a kind of subset of the component pattern? It's like the way we use the command, you just like plug in the command, right? And that's kind of this component.
Yeah, well, commands don't have to be hooked into that update cycle, right? Commands can, we hooked them in there, we gave them an execute, but they don't have to have that. And commands are also something you don't want a bunch of them running at the same time. So if we did another version of the command pattern, we pushed it a little farther and it wasn't like assignment 1, we'd actually start making command queues, which you'd put a bunch of commands and then those would be ran in sequence or potentially in parallel, depending on what we wanted to do with the character. So they're a little different in nature, but their decoupling logics are pretty similar, right? They still can all be placed into a command slot, a collection of commands that is ordered in some way. Yeah, so it's a good point. They have they have some commonalities, and strong ones at that. Any other questions or comments? Think you understand how Unity works at the level of game objects a little better? Hopefully this is a little bit of revelation. Was there code in here you didn't understand? Oh, go ahead first.
Sorry, so for
Yeah.
the next page, the diagram, it doesn't see any connection between object.
It's because there's no inheritance structure between them. It's simply game object has a collection of components as one of its properties. Yeah. So notice you can't put a game object into a component of another game object. Now there's a difference in the hierarchy, right? So you on the visual hierarchy or the hierarchy editor, you can put a game object as a child of a game object, but that's different from component structures. Components are within a game object. Yes?
So, did Unity ever talk about why they had like the overarching parent like objects class? Like what's the purpose that serves?
A lot of that has to do with debugging, caching, making things efficient at the engine level. Their ability to manage all the things from within the engine makes it easier when they have a top-level hierarchy. And if you're working in an object-oriented system, you have to have the hierarchy always has a root somewhere, right? And object isn't the full root, right? Because it's in C#, so it probably has system.object as the real root. I'd have to inspect that. That's my intuition on how this type of thing is done in other languages. Yeah, because that everything that a programming language knows about classes in these classic like C-ish languages, comes from a top higher level object and then it branches down from there. Everything inherits from a top level object. It's a tree, not a forest. Yes.
I have a more general question about the name convention.
Uh-huh.
When do you put the underscore before the variable name? When do you put
Oh, that's sort of a C++ ism. Some folks when they write C++ like When things are private, they put an underscore after it. Or when it's an attribute, they'll put an underscore after it. Some people put an underscore before it. If you're in C, you tend to put like a letter denoting the variable type in the variable name itself, right? These are just, those are various C++ conventions that we're dealing with here that, you can look at the style guides for each language and see how they handle that sort of thing. It's a lot less of a big deal to put that sort of information into your actual programs now, because we have so much tooling around that you're going to get like a syntax color, or you're going to get a context sensitive pop-up or something in IntelliSense that's going to give you that same information in a way that you don't have to actually add keystrokes to your code, right? Which is why we tend to handle things with like Camel case and Pascal case and like the newer design languages like C#. Still about the same number of keystrokes, but you know that you're working within an ecosystem of a whole bunch of other context cues. What else? You guys have been awful quiet the last 2 classes. What's going on? Questions? Yeah.
So I'm a little confused on the purpose of the mono behavior.
So a mono behavior is the entry point for you being able to add your own scripting to an object. Otherwise, you have no way of adding code to it. Other things are prepackaged components that you use, not ones that you author. So mono behavior, I don't know why they call it mono behavior. Actually, I knew at one point. There's a couple of, I think, blog posts in Unity's thing where the developers have talked about the history of mono behavior. There's a certain like lineage that it came from, and they just never really updated the name to something more reasonable.
So it's just a script that you can add or a behavior that you can add a script to.
Yeah, and even behavior's a little weird, right? So behavior's a really abstract term. It's not like we think of as human behavior. It's like, how should a component work? Right? And that component can be just about anything. Like look how flexible the mono behaviors are when you create them, right? They can touch all sorts of things from abstract game logic to rendering. So it really, like mono behavior, I wouldn't get too hung up on that name. It really is you adding your own component that you can write the code for. Yeah.
So why is Collider 2 inheriting from behavior but not Collider?
Ooh, that's a good question. I don't actually know the answer to that. That's something we should look up. That's bizarre. That sounds like maybe it's not a perfect game engine. So one insight there is they have had multiple physics engines associated with Unity. They used to have their own. Then they bought a competitor middleware engine called Havok that did physics. And so now that's part of Unity. And then they also started integrating Box 2D for the 2D engines. So they have 2 different physics engines depending on whether you're 2D or 3D. They use Box 2D for 2D physics and Havok, or their 3D physics engine, for 3D stuff. And maybe that was just for some architectural reason had to live at 2 different places. I don't know. That'd be interesting to find out. Yeah?
How does the component architecture differ from the Unity component system?
Oh, in pretty interesting ways. So let's see. With the game component system, you have like a bunch of game objects, and all of them have their components associated with it. And for every update cycle, you go through all of your game objects, and then you update all of the components, right? And you do this for each game object. And they sort of happen in like this undefined order. And who knows where those game objects are kept? Or like usually some probably associative array or linked list somewhere. So there's they're sort of like programmed in to handle very dynamic environments, or dynamic ways that they're invoked and used, and in various places within the game object, or in your game world. So they're very flexible, very dynamic. Now the entity component system gives you several restrictions. One of which is basically like when you define a game object, or when you define entity and components, they're all structs. So you don't actually, you can't associate code with the data directly. You just have these data objects. And then any entity that is part of the entity component system is, they're defined by their signature of the number of components that they have. So like a movement component, a graphics component, a component that deals with collisions. All of those are different. So like players would have all those three, but maybe a background world object wouldn't have collision, but it would still have a position and graphics. So they would be kept in different areas, different chunks of memory. So for each one of these various components that have a different signature, they are kept in memory local chunks for for very fast iteration through them. And each chunk has its own signature. So things that were only physics would be in one chunk. So they could do a very fast physics only loop update for those things that are structs inside of this very local memory space. And then basically they're organizing, giving you various restrictions to organize your code around performance. So they know for every, that you can do some caching, you can do some memory local stuff, you can load all of the code that you need for doing the things that are physics, movement, and graphics all in one chunk. They know all those three memories, all those three operations that you've defined, those classes, those methods that operate over those that you've defined will be ran over those in tight succession and order. And then when you do the things that are only physics and location, then you only load those two physics and location methods, and then you can quickly run through those as well. So you have a lot of memory locality, you have memory chunking, you have only loading the context and procedures that you need to operate over those particular layouts of components. And that's one of the huge differences from this component system that we've described here, that the basic game object version of Unity uses. And if you look at the demos of ECS, I mean, you get like 2 orders of magnitude worth of performance out of this switch in complicated scenarios. It's meaningful. It's also very hard to write the ECS code. It's there's a lot of boilerplate involved, and it's very particular. Did that give you enough surface to start with?
Yeah.
Okay, cool. We can talk about that more, particularly in office hours. I've got some good tutorials on it. I've been futzing around with it myself, so I'm happy to help you explore a little
Okay, thank you.
to make really fast code. Now, it really helps if you have a bunch of stuff. Like the demos are compelling, like ants moving around, terraforming a world type of things, where you have thousands of ants moving around, all being independently animated and moving at their own discretion, which would, you saw like when we built the tree, the procedural tree, how slow that got after we had like 300 or 400 game objects. Well, if we would have done that ECS, I mean, we could have probably, I don't know, the speed up would have been pretty darn astounding. So I've been thinking about swapping that over, but that'd make it that'd make an intro to ECS late in this class, as opposed to, hey, look at this cool thing at the beginning of class. So it could be good to have both of those. Like, if anyone wants to go renegade and try to make the ECS version of that procedural tree thing, I will give extra credit for that. That shows engagement. Be happy to see it. All right. Anything else about this? Hopefully, for those of you who haven't had the software design pattern breakdown before, maybe you've learned something. Hopefully, components will be something you understand better, or maybe add to your future projects. All right. Shall we do some class announcements? Let's do some class announcements. Okay, so I'll kick it off, and then Kyle, just flip on your microphone whenever you're ready. And maybe step up here as well so we capture you on the recording. You are now done with exercise 3. You're now working on exercise 4. Hopefully the factor pattern is working well for you. So you've noticed that we've had 2 types of assignments, some that are more scripted out for you that you fill in. 1 and 3 were that. We've had some more open-ended ones where you're more responsible for the implementation of the design. So we've had 2 and 4 for that. Particularly exercise 4 here, the last stage is pretty complex, right? I'm asking a lot of you. A factory of factories, building a schedule that you can then run and execute, right? So you're starting to get in some fairly complex game logic, game programming, gameplay system programming. How's it going? Have any of you gotten to the last stage yet and started? Okay, all right. Well, we can maybe do some stuff during office hours. I didn't have time to prepare it today, but during office hours, I'm happy to show off a key, showing how that works. So if you want to attend, then we could even record it potentially. if there's enough people that ask for it, and then I can post that as well. I'm sure a lot of more people would be interested in seeing it than can actually physically make office hours. So I'll see what I can do for that tomorrow. Peer reviews, you've gotten some grades back. There's been a few, like every year there's always some small hiccups. So I think we're resolving a lot of the issues. Now, something I want to check in with you all on is exercise 4 versus exercise 3. So there was some bizarre thing that happened that I have not found the technical reason for, where some people, when they were given their repositories through GitHub Classroom, the default repository was set for an archived branch from like spring 2019 that I had for the project, right? Can I just get a raise of hands if that sort of happened to you? Right, so that was my intuition. It happened to about a quarter of the class, maybe a third. And I have no idea how this happened, and it certainly didn't happen to everyone. And the process was the exact same for each of you. So I'm a little flummoxed as to why this happened. So let me know if that's happening for exercise 4, and we'll try to solve it for you early. There is an archive branch in exercise 4. It's not as old as the one in exercise 3, but I still I want you working on master, so you all have a standard playing point. You're all working from the same surface. Okay, so has anyone had this happen for exercise 4 yet? Have you got the emotional damage branch, the M damage branch? That happened for exercise 4? Did that happen to you? The default changed? Okay, so let us know if this happens. What we'll do is we can, one of us will take admin control of the branch and swap the default over and then send it back to you. So if this happens to you, please let us know. We will fix it for you, okay? All right. So now you're working on your peer reviews for exercise 3. When you're putting in peer reviews, put them in the master branch. Nope. Oh gosh, this is now complicated. So Kyle, maybe you want to address some things now?
Yes, here we go.
Okay.
Test. We're on. It's on. Test.
You can just use mine if you want.
All right. No, that's fine.
I wonder if you're piping into another room. That's happened several times to several people.
Oh, jeez, really?
Yeah. It happened to us
Interesting.
in one of the first classes.
So, peer reviews for assignment 3, they went out this morning. We didn't realize that the default branch is affecting so many of you. So what happened was it appeared as not submitted in GitHub Classrooms. So the first round, after I made that announcement, those are the people that it was actually showing submitted for. So if you're one of those people, then either you have, I think you should have master as your default branch already. Everyone after, it's already solved. I've gone into each of your repositories and set the default branch to master. And you should have received an email. So everyone should have a peer review by now. As you go through your peer reviews, please check that you are reviewing the right branch. You should be, given that all branches are now set to master default. Just, if things look off, look around, don't panic. Look around, see what the last commit was for, yada yada. All right, that's it. If you do not have a peer review still, then you either did not submit or something went horribly wrong, so please contact me. All right, great. That's it.
All right, excellent. Thank you, Kyle. And so, Kyle, please just let me know if this will delay grading at all so we can send out that message.
It should.
Okay, thank you. All right, so I don't think we actually have enough time for spell factories now, so we'll probably push those off. So for the people who have done spell factories, there may be a revision that you want to make because a lot of you, I think, looked at the past spell factories and maybe missed a detail that's important. Let me get to a browser here. There we are. All right. So a lot of you, when you made your spell factories, you didn't put them in a folder. You used a basic folder layout of the Unity project and simply exported that. Now, what happens is when you import that, that blasts over everything that was already there. So here is an example of what you want to do. See this top level shared spell factory folder? You should make a folder for your package that everything your package contains should go within. And you want to make sure that the things you include are things that should be included. So a lot of folks were including like the universal rendering pipeline asset that was part of the package, and the scene file that was part of the package, and all of the previous prefabs that were part of the package, whether you'd use them or not. So there were a lot of black holes, there were a lot of fireballs, a lot of the original components were also submitted along with your factories. So think about like when you're sharing code, like what should be shared and how should it be presented? How should it be imported to someone else's project? In this case, putting things in your own namespace and making sure you're in your own folder space is pretty critical. All right, so you may want to go back and do a light revision. That shouldn't take a whole lot of time. Make a new folder, put your stuff in the new folder, make sure it all runs in like a blank project or something. And that's sort of like the standard, because I'll be pulling these into the Spell Factory project and seeing if they work standalone. So basically, I want to be able to import your package, go into the folder that you've named for your package, find the Spell Factory prefab, and just drag that onto my scene. And it should work. So this is a really building components, building packages that other bits of code can use. Plugins, these are often called for various platforms, is an art and a skill. You should, something that's very valuable to master. I recommend you do that. A lot of times you even use this on teams as well. That way you can independently work on independent functionality and then bring those together in a larger project. Right, so this is, this is definitely worth going through and making it right. Okay. Any more questions? Concerns? You're almost done. We're going to start making teams next week. I'll be talking about making teams. Since we don't have any more exercises to talk about, that will be the topic of our discussion section. So now is the time to start thinking about who you want to work with. And if you want to get started on that, you can go to the gameplay programming folder and you can see some basics. So here in the gameplay programming folder, we have our project pitches. So we'll see if we'll have time to actually do pitches this year, but putting together like the basic idea of your game in a way that can be communicated to others will help you in making your proposal. That's one place to get started. Another is our project document template. So you'll actually be submitting one of these with your final GitHub repository. And this will say, this is basically some of the documentation we're going to ask for you for the project. And a lot of it is dealing with your main roles. So we've defined some main roles for you. So nominally, we've made team sizes 5. And so each person will take a main role and a sub role. The main roles being producer, user interface, movement physics, animation visuals, input, game logic. Wait, 1, 2, 3, 4, 5, 6. Okay, we did expand it to 6 this last year because we had a big class size. And then sub roles, cross-platform, audio, gameplay testing, narrative design, press kit to trailer, and game feel. So these are a standard set of roles. We encourage you to use them, but if your game design doesn't really fit this very well, you can customize your own. They have to be part of the proposal, and you have to tell us what the design is, what the criteria for success for, and how you think you should be assessed for that role. So you have a little extra work to do if you want to customize your roles. That's one thing we're looking for. Going to Canvas Oh no! What? Shibboleth, why do you do this to me? Nothing like stochastic errors, right? I didn't get a lot of feedback on what I was doing wrong there. Okay. So you could also look at the project plan and registration spreadsheet, project group registration spreadsheet, initial project plan document, progress report documents, and the press kit and trailer information document. So all these are bits of supporting information to help you on your project. This first one here is you can even go in today if you want, if you know who your group was, put in a group name, make a GitHub repo for it, start giving us a link to your Google Doc and the initial plan. So all these green areas are things you should fill in. Team members, we have drop-down lists for the basic ones. You can add your own if you want to add another main role. You can just nuke this and write your own in. And this is the basics here. But what's really cool about this is if you scroll over here, there's looking for group section. There's looking for member section if you want to add people to your group. So if you're unsure on who's looking for groups or who needs groups or whatever, if you want to do some group formation, here are 2 places for you to go to. You could also go in the looking for group channel in Discord, or looking for member channel. We also have the last 2 years of full projects. So you can go through and see their GitHub repositories. You can look at their game plan documents. You can see like the final version. Like some people posted the WebGL versions of their games. Like you can play Cardcaster. Maybe. Ah, there we go. Took a minute to load. Cardcaster. Doo-ba-doo-ba-doo. Pew, 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 pew. Oh god. Okay, I died. That's what happens when you're playing with like your pinky, because you're holding a microphone. Right, so you can see, you can even play some of the outputs from previous classes just right here in the spreadsheet. So I like really sharing as much information with you as I can. So feel free to do this and do better than the last class did. You can see we had a bigger class last time. We had a lot of games, a lot of documents to choose from. That's 2022. We have 2023, which is like probably the largest version of the class. Some even put me in, which is a little embarrassing. McDungeon. Yeah, so feel free to go and check these out. If you look inside of the gameplay programming class, this is my version. So if you go to the public here, you can look at even some more past demonstration videos, game builds, lecture recordings, that sort of thing. The demo videos, since this was pandemic-y time, we have some of the videos for you to look at from the presentations and demos for your fellow students. All right. And this was when we did presentations for the final project. Traditionally, we just do an arcade where we go around and play each other's games. I think it's a lot more fun, and you get a lot of hands-on experience and talk to the developers. So you want to take teams, take turns, one person at your team there helping people play your game, and other people, and the rest of the team can roam around and play all the other games. Much more of what game developers do than give demos and pitches. All right, progress report. Okay, here's the initial plan document. So really core concepts, describe what's going on with your game, talk about your team. Each one of you signed up for a set of roles. Here's where you can start thinking about customizing your roles and let me know some basic info. Scheduling timeline, so just filling in good faith each one of these basic bits of information will be your interface in creating your own game. All right, I think that's about all we should talk about today because I need to go. And for those of you who want to see the AI candidate speak today, I will be walking over there directly. Feel free to join. Should be a good one. This is the beginning of our AI candidates for the next, 2.5, maybe 3 weeks. We're going to have sort of like the best of new graduates, new PhD graduates that could be easily professors just about anywhere in the world, talk about their latest and greatest work. It'll be fun, inspirational. Let me know what you think about these people, and we'll factor in your comments in the hiring process. All right, thank you all. Have a great day.
I'm announcing the theme next week. I'm announcing the theme next week for the game projects. There's a theme.